So this is the problem based on stoichiometry. So we will see some problems of this kind of questions. Equal volumes of 0.1 molar silver nitrate and 0.2 molar NaCl are mixed. What will be the concentration of nitrate in the mixture? So we can write here equal volumes means write equation silver nitrate plus NaCl. So they will give you a product AgCl plus sodium nitrate. So this is your 0.1 molarity and this is your 0.2 molarity. Okay, so equation is balanced. This equation is balanced. On balanced equation 1 molarity 0.2 molarity, so this will also give 0.1 molarity. So here volume, there are two volumes are there. So concentration of nitrate ion in the mixture will be, this will completely convert into sodium nitrate. So total concentration will be 0.1 and volume will be 2. So we will get here 0.05 molarity. So this is our problem. Next problem. What is the minimum quantity of H2S is needed to precipitate 63.5 gram of cuprous ion nearly? So here we will see here moles of Cu2 plus is equal to moles of H2S. So this equation is based on principle of atomic conservation. Okay, so since 63.5 gram, if you divide it molar mass of copper, we will get here 1 mole. So 1 mole of cuprous ion is required to convert same mole means 1 mole of H2S. So 1 mole of H2S will be how much gram? So hydrogen is 2 gram and sulfur is 32, so this will be your 34 gram. So this much gram of H2S is required to precipitate all the cuprous ion nearly. Now next is 1 mole of ethanol is completely burned to carbon dioxide and water. So what is mass of CO2 is formed? So we will write here formula. So 1 mole of methanol means write here C2H5OH is methanol and we are burning in presence of oxygen. So we will get here CO2 plus water. So what is the mass of CO2 formed? Here we are asking how much mass will be formed. So if you balance it, this becomes 2 mole. So for this one we require 2 moles of CO2. We require 2 moles of CO2. So this is your 2 mole of CO2 is nothing but it will be a 2 into 44, that is 88 grams. So this is our answer. So these questions are not difficult if you see. Okay, so the thing is how you are understanding the problem. So now we'll see next problem. So in this problem, what is the mass of oxygen that is required for the complete combustion of 2.8 kilogram of ethylene? So ethylene is C4H4 gas and we are burning in presence of oxygen. So any hydrocarbon, if you burn it, it will give you CO2 plus water. So here we can balance this 2 carbon 2 is there. So again oxygen is 4 plus 5. So here so this is your 4 hydrogen. So here we have to 2. So hydrogen also balanced. So oxygen will be 6. So here we have to 3. Now what is the mass of oxygen that is required for the complete combustion of 2.8 kilogram of ethylene? So molar mass of ethylene is here 28 grams. So 12 into 224 plus 4 28 grams. And we require 3 into 32 90. This will be your 96 gram. So for 28 gram we require 96 grams. So for 2.8 kilogram will be how much? So answer will be here 96, 28, 96, this will be your 96 by 28 multiplied by 2.8. So answer will be here, if you cancel it, this will be your 9.6 kilogram. So this much kilogram of ethylene is required for the complete combustion. What is the percentage loss in mass after heating a pure sample of potassium chlorate? So potassium chlorate formula is KClO3. So if you heat it, they will give you KCl plus oxygen. So here you balance it. So 3 oxygen is there. So put here 2. So on putting, this will be 2. This will be your 3. So what happens? So molar mass of this is 245 grams. You calculate it. Potassium 39. Potassium is 39. Chlorine is 35.5 and oxygen is 16 gram. So 16 into 348 gram. So if you multiply it and multiply double it, you will get 245 gram. Okay, so 240 gram here. Mass loss means oxygen is losing. So oxygen is how much? So 3 into 32, that is 96 gram. So again they have given, if it is percentage, suppose it is 100 gram KClO4 is given. So what is the loss of oxygen? So for mass loss of oxygen is 96 divided by 245 into 100. So here you will get answer 39.18%. So this is the percentage loss in mass. Now next is, what volume hydrogen gas at 273 Kelvin and 1 atmospheric pressure will be consumed in obtaining 21.6 gram of elemental hydrogen. So atomic mass of elemental hydrogen is 10.8 gram. From the reduction of boron trichloride with hydrogen. So we have tried boron trichloride plus hydrogen. So here we will get here boron plus HCl. So if you balance it, so there is 3 HCl. So here if you write 3, okay, and there is 2 hydrogens, so again you have to write some positive value. So put here 6, here put 6, see, and the Cl is there, so 6 Cl. So here we have to put 2, there you have to put. This is your balanced equation. So here molar mass of the elemental boron is given here 10.8 gram. 21.1 gram of elemental boron. Obtaining this much gram, how much hydrogen will be consumed? So one boron they have given 10.8. So here we have 2 boron, so 2 into 10.8 gram of boron. So we require, this is the 3 into 22.4 liter of hydrogen. Why 3? So 1 mole of hydrogen is 22.4 liter STP. So for 3 mole we require this much moles of H2 as hydrogen gas. But we are given how much elemental boron? 21.6 gram. To obtain this much elemental boron, here we are requiring 2 into, so this we got 10.8 gram. So this we are writing, so 2 into 10.8 gram we require this much oxygen. For this much boron we require this much oxygen. So suppose if you take 21.6 gram boron, so how much we require oxygen? So 3 into 22.4, so multiplied by 21.6 and divide by 2 into 10.8. So after solving we require 67.2 liters of hydrogen. So this much hydrogen will liberate elemental oxygen 21.6 gram. Now here is the dehydration yield of cyclohexanol to cyclohexene. So this is the compound is 75%. What would be the yield if 100 gram of cyclohexanol is dehydrated? So this is given, had dehydration means removal of water. So cyclohexanol formula is C6H13OH. So on heating water is released, so we will get here product C6H12. So this is your cyclohexane. Cyclohexene C6H12 cyclohexane means one will be your double bond. So weight of molar mass of this is 102 gram and molar mass of this is 84 gram. Okay, so for 100 gram percentage they are asking how much will be there. So 84 by 102 multiplied by 100. So this much gram of C6H12 we obtain, but we have to obtain 75% because yield is 75%. So 75% yield, percent yield will mean this is your theoretical mass. This mass will be your theoretical, but we want practical. Experimental will be how much? So experimental will be on solving, so we will get it 0.75 because 75% is given and multiplied by this theoretical mass, so that will be your yield. So on solving we will get 67.769 gram of C6H12. This is the 75% yield. Next problem is, lithium oxide is efficient absorbent of carbon dioxide in spacecrafts. So in terms of absorbing capacity per unit mass, if the reaction is is like this, lithium oxide next to CO2 is this is giving. So what is the absorption efficiency of pure lithium oxide in liter CO2? That is at STP per kg. Okay, so we have to find out the absorption efficiency, okay, in per kg. So we have to write the equation. So lithium oxide plus CO2, so it will give you your lithium oxide plus carbon. This is the reaction given. Okay, so this is your, again this is balance, this is your again 1 mole. So 1 mole we are requiring 22.4 liter. So this is 1 mole of CO2 means 22.4 liter at STP. Now for 1000 kilogram they are asking per kg. So if you take here 1 mole is your 30 gram. You can see here 30 grams is lithium is your 11. So lithium is your 7 into 2 14, 14 plus oxygen 16. So 14 plus 16, if you add it you will get 30 gram. So if you take here 1000 gram, because per kg they are asking how much efficiency of lithium oxide, how much CO2 will be required per kilogram, per 1000 gram. So answer will be 22.4 liter divided by 30 into 1000. So here you will get answer 746.66 liters of CO2 we require for the absorption of lithium oxide by this one. Okay, so now next problem is, we'll see here. A sea water contains 65.10 per minus 3 gram per liter of bromide ions. If all the bromide ions are converted to produce Br2, so how much is sea water is needed to prepare 1 kilogram bromine? Okay, so they are asking. So this much bromine is this much bromide ions is present, and again we have to use the principle of atomic conservation here. So how will use? So here we write Br ions is converted into Br2. This is given equation. All will convert to this much, as this is a 2 mole. So again here we use PuAC convert. So all the bromine is converted into bromide ions. So we can use moles of bromine equal to here moles of bromine. Okay, so here bromine is, so weight by 80 gram moles. This will also weight they have given. So we had required how much? 1 kilogram. So this will be your 1000 divided by 80. So here weight of the bromine will be, weight of the bromide ion will be we require how much? 10 per 3 gram. So this much ions, bromide ions will require to convert this 1000 gram of bromine. Okay, but this is in 1 liter. So this much is present, this much gram contains bromide contains in 1 liter. This much bromide ions is present in 1 liter of sea water. Okay, so again how much sea water requires? So sea water required to get this much bromine ion is required how much? So 3, this much we require, and divide by how much? 65 into 10 power minus 3. Okay, so we will get here 15.38 in 15.38 into 10 per 3 liter. So now question comes, see here. So 65 into 10 per minus 3 gram for we require 1 liter. So if you take 10 per 3 gram what bromine ions we require how much liter? So definitely we write here 10 per 3 by 65 into 10 per minus 3. So this much we require. That's why we are writing this is. Okay, so on solving we will get this much liter, or we can say 15.38 kiloliter. So this is our answer. So we have to understand how this value is coming. So it is coming from here. So now we'll see. Calculate the amount of calcium oxide given required to react completely with 852 gram of P4O10. Okay, so calcium oxide is reacting with phosphorus pentaoxide. So phosphorus pentaoxide P4O10. So this is the 2 molecules of this one, phosphorus pentaoxide. So we will get here calcium phosphate. If they react, they will calcium phosphate. So this is the triatomic molecules. We will get this one. So now this balance this reaction. So on balancing, we will get here 6. This is 2. So this is a balanced reaction. So amount of calcium oxide react, and they are acting 852 grams. So this is actually 6 into 56 gram. Okay, and here we require how much phosphorus oxide? 284 gram. This much we require. Phosphorus is 31. So 31 into 4 plus 10 into 16. So this will you get 24 gram. Okay, so for 852 gram, how much calcium oxide is required? So it is very simple. 244 we require 6 into 56, and if you take 852, so we require 6 into 56 divided by 284 multiplied by 852. So very simple. On solving we will get 108 grams. So this is our answer.